This is Cisco Training 4. Today we're going to configure an Ethernet link between our two routers, and we're going to configure IP addresses on it so we can ping each other. This is an Ethernet transceiver. At this end we have what's called an AUI port, which is an old 10 megabit Ethernet standard. At this end we have a RJ45 port which has 8 pins on it. Ethernet uses 4 of those pins. That's sort of the normal Ethernet cable that you're used to. On our router we have, this is our 2511 router here, an AUI port here. And then on our 2514 router we have 2 AUI ports. So this thing here can click left and right, and that way there's little nuts on the little protrusions here. You can't really see them. There it is. See the little protrusion? The thing that switches to the left and the right here can lock into that. So let's try to plug this in, and then in theory now I could lock it to the left and lock it in place. If this were in production, I'd want to lock it in place. And then on the other router, I'm going to do the same thing. There, now I have my, the routers natively come with the AUI ports, but now using the AUI to 10 base T transceivers, I now have RJ45 ports. Great. Now what I need is a crossover Ethernet cable. This is one of the cables that you wanted to buy. You can buy it at normal electronic supply houses, Fry's. I would hope that Radio Shack would have it if it. Here we are, the normal RJ45 ports that you're used to. In a minute I'll show you the pinout, but for now I'm just plugging it in. The pairs of transmit and receive are reversed on this cable, and there we are. Our physical layer is set up for our Ethernet point-to-point link between our routers. The network engineers have something called an OSI model. It's a 7-layer model for networking. The first layer is the physical layer. The second layer is the link layer. The third layer is the network layer. Later on, we're going to go in all 7 layers. When you're debugging stuff in a network, it is best to debug your physical layer first, and then to debug your link layer, and then to debug your network layer. So we just completed the physical layer of our network. We'll power on our routers, and we're good to go. Actually, let's power it off for a second, because I also want to cable up the synchronous serial ports. Let me show you another type of cable. This is a DB60 connector. It has 4 rows of 15 pins each. It's sort of a fragile connector. It's very easy to bend the pins, and it plugs into the synchronous serial ports here and here. The other end of this cable is very weird. This is called a V35 connector. And it's got a bunch of pins sticking out. Because the pins are sticking out, this is referred to as a male connector. This cable is a synchronous serial cable. So this is a synchronous serial DB60 male to DB35 male DTE cable. Now, how do I know that it's a DTE cable? What does DTE mean anyway? DTE means data terminal equipment. The alternative is DCE, data communications equipment. When you're connecting routers together, one end needs to be DTE and one end needs to be DCE. That's when you're connecting together with a synchronous serial cable like this. So the way I know this is DTE is on the label on the cable, it actually says V35 DTE. All right. Now, if this is one cable that you can commonly scrounge, because a lot of network gear had this and plugged into telecom gear, the corresponding cable for this would be a DB60 male to V35 female DCE cable. and then you'd plug the V35 female cable into the V35 male cable, and you'd be set. The problem is there aren't too many of those DCE V35 cables because they didn't get used very often. Now you can order them special, but what I recommended in the first session was you order the special cable. This is a DB60 male to DB60 male cable. It's DTE on one side, DCE on the other side, and that it's just 1 foot. It's nice and short, nice and easy, and that way you can just plug it in. So I'll plug the DB60 into one side, and that's the DTE side, and on the other side I'll plug in the DCE side. Now, even though this is a lab, you don't want to go plugging these and unplugging them all the time. You want to plug them in once and leave it that way. We're going to build a triangle. So once, if you've scrounged cables, you plug these in, you build your triangle, just leave them plugged in. If you're constantly unplugging and replugging them, then you're going to bend a pin, because there's 60 pins. They're pretty fragile. It's real easy to bend them. And after about 5 or 6 unplugs, you're going to bend a pin, and then you're going to have to go buy another cable. So just plug it in, leave it set up forever, while you're doing your training. There we are. So that is now done. We've configured our physical layer. Now let's configure our link layer. Here we are in our router console. We need to enable. I have no enable secret set, so when I enabled, I didn't need to type in a password. I do a show IP int brief. This is my 2514. I have 2 Ethernet interfaces, each of which is one of those AUI interfaces you saw with the first one. Ethernet 0 is the one where I put on the transceiver, and I have 2 synchronous serial interfaces. The first one is where I plugged in the synchronous serial cable, and they are both what's called administratively down. So to bring the link layer up so that the routers can talk to each other on the Ethernet level, I go conf t int Ethernet 0 no shut. That's it for Ethernet. Now I have some log messages that came out. The first sys5 config configured from console by console. Just a log message indicating, hey, this router was configured. The next one is interface Ethernet 0 change state to up, and then line protocol on interface Ethernet 0 change state to up. Meanwhile, on my transceivers, I have a green link light. I'll do a show IP int brief. My Ethernet 0 interface is, the IP address is unassigned because I haven't done anything in the network layer. My status is up, up. Now I'm going to plug my console into my other router. Now I'm on the other router, so I enable, show IP int brief. Here my Ethernet 0 interface is administratively downtown. So conf t Ethernet 0, int Ethernet 0, no shut. The other thing I'm going to do is I'm going to, so I have the same log messages. Notice I typed end to get out of configuration mode back to enable mode. Let's go back into conf t mode, configuration mode. Hostname, this is my 2511, so I'm going to type in hostname 2511. Show IP int brief. And I see my interface is Ethernet 0, status up, up. Let's do a show CDP neighbors. This is interesting. CDP is something called the Cisco Discovery Protocol. Cisco network devices send Cisco Discovery Protocol frames out every port, I don't know what the timer is, might be 60 seconds. And so I do a show CDP neighbor. The other router sent me a CDP frame, and it said its device ID was router. Again, that was the router where I had not changed the host name. That's my 2514. The local interface on the other side is Ethernet 0 the local interface on my side is Ethernet 0. The hold time is 154 seconds. What that means is this CDP message will stay in my neighbor cache for another 1.5 or 2.5 minutes, another 154 seconds. Capabilities are that device that sent it to me, the CDP to me as a router. It's a platform 2500, and its port ID is Ethernet 0. So I know that the other router's Ethernet 0 interface is connected to my Ethernet 0 interface. And I didn't need to trace a cable to do that. When you're debugging network problems and you want to see whether your link is up, show CDP neighbor. And there you are. Now what that means is our link layer is working. Again, back to the OSI model. The first layer is physical. The second layer is link. The third layer is network. We can't ping the other router yet because we have not set up IP addresses. That's a network layer function. But because we're seeing the CDP neighbor, now we know our link layer is up and operational. So let's go ahead and get our network layer operational. conft int Ethernet 0. I'm going to set my IP address 10.0.0.1, 255.255.255.0. My IP address is 10.0.0.1, and my subnet mask is a /24 because I have 24 bits set to ones, and then the rest are zeros. Bad mask /24 for address 10.0.0.1. Why did that happen? Let's look at my config, and what I don't see here is IP subnet 0. I see IP classless, which we'll talk about later. That IP address that I tried to configure, if you remember from the classful IP addressing, this is 10, so the first bit is 0, so this is a class A. So the first 8 bits are the network in the classful IP address sense. The next 16 bits are the borrowed bits. We borrowed them from the host portion, and we were using them for the subnet mask. But the subnet mask, we're using that for the subnet. So this is what's called a subnet 0 situation. And Cisco routers running older versions of iOS do not allow you to configure subnet 0. And then if you have a moderately old iOS, by default it does not allow you to configure subnet 0, but you can type in an IP subnet -0 command and then it'll work. conft IP subnet -0. There's a dash there. There's a dash here, it just didn't show up in my terminal window for some reason. And now int Ethernet 0 IP address 10.0.0.1 255.255.255.255.0. And this time it works. So that's what the IP subnet 0 command did. Now I'm done. I want to save my config. The Cisco router has a running config and a startup config. Here, let me do my show run to show my running config. And you can see that the IP address is there and my IP subnet 0 is there. Now let's do a show start up -config. Non-volatile configuration memory has not been set up or has bad checks on. We haven't saved a startup config at all. If we reboot this router right now without saving our config, then we will lose all of this work and our network will be down. That's not a good thing to have happen in production. So I do a write mem. Building configuration, it takes a few seconds. 2511 is sort of a slow CPU. Show start. Now if I do a show start, you can see it says it's using 383 bytes out of 32,000 bytes possible, and there's our IP address. Great. Now let's go back to the first router. We've configured an IP address on the 2511, but we have not configured an IP address in the 2514. Conft hostname 2514, and let's do a show CDP neighbor. Show CDP neighbor. Out my Ethernet 0, I see a device with a host name of 2511. My hold time is 155 seconds. Capability is router. Its port that it is facing us is Ethernet 0. So my Ethernet 0 interface connects to the router named 2511 interface Ethernet 0. Conf T, int Ethernet 0, IP address 10.0.0.2, 255.255.255.0. It accepted the command. Again, this is a subnet 0 situation. It's a class A, so the first 8 bits are the normal classful network, but then because we're using a /24, we borrowed the next 16 bits for the subnet, but all those bits are 0. So why did it accept this? And let's do a show run. And it says IP subnet 0. So, and I did not configure that. That is by default in this version of iOS. Notice the version is a 12.0 version in the config. If you remember from the previous router, I didn't point it out, but that, if you look back, you'll see that that version is an 11.3 version. So the 2511 has an older iOS version which does not have IP subnet 0-0 enabled by default. But this iOS version 12 router does have IP subnet -0 enabled by default. If I wanted, I could type in no IP subnet 0. But I don't want to do that. Okay, so I've configured my IP addresses on both sides. Let's ping 10.0.0.1, which is the IP address on the other side. The first ping resulted in a dot, which is a failure, and then the other pings succeeded. You'll see that a lot in the lab. What's happening is you're sending the packet out over Ethernet, and so you need to figure out the Ethernet address of the remote IP address. There's a protocol to do that called the Address Resolution Protocol, or ARP. So I will explain ARP in a later session, but for now, all you need to know is that the router needs to send a ping to a packet to 10.0.0.1, and it does not know the Ethernet address of 10.0.0.1. It knows the IP address, but not the Ethernet address. The IP address is a layer 3 address. The Ethernet address is a layer 2 address. So it tries to send the packet to 10.0.0.1. It can't because it doesn't know the Ethernet address to send it to. So it generates an ARP request, but the router does not save the packet until the ARP request is responded to, because we don't want routers saving packets. Routers aren't very good at that. So we drop the packet. But the ARP request goes out, and by the time we send the next ping, the ARP reply has come back. The ARP reply has the Ethernet address or MAC address of the remote side, and the pings succeed. Now let's do a show ARP. I do a show ARP, and I was pinging my IP address is 10.0.0.2, and it says it has my own Ethernet address here for that. The age is a dash, which meaning that will never age out because it's my own physical Ethernet address. Now I have but for IP address 10.0.0.1, the Ethernet address or the hardware address or the MAC address, those all mean the same thing, for the other side are 0010.7BE8.3367. This is a different address format than what you're used to. You're used to a 32-bit address format for the IP address. This is a 32-bit IP address, which is a network layer or layer 3 address. This is an Ethernet address. It is 48 bits. Each character here each digit is hexadecimal. It can be 0 through 9 or A through F. So like an A is a 10, and B is 11, C is 12, all the way up to F is 15. Each character here corresponds to 4 bits, because if in a hexadecimal character you have 16 possibilities, that's 2 to the 4th power. So 4, 8, 12, 16 bits here, 16 bits here, 16 bits here. So an Ethernet address is 48 bits. Every Ethernet interface in the entire planet is supposed to have a globally unique Ethernet address. The first 24 bits are assigned to the manufacturer. So you can actually look up, there are places on the internet where you can look up 00107B, and you will see that that Ethernet address is assigned to a particular Ethernet card manufacturer or router manufacturer. Very good chance it's registered to Cisco. And then the last 24 bits are for the part of the Ethernet address which is assigned by Cisco, or the manufacturer of that particular Ethernet card. Our Ethernet link is now done. We can ping across it, we can see CDP neighbors across it, we can see the ARP entry for the opposite side. Let's deal with our serial interface. So show IP int brief, and our serial 0 interface is, our IP address is unassigned. We're administratively down. So let's conft int serial 0 no shut. Show IP int brief. That was a little, the command is show IP interface brief. Serial 0 is no longer administratively down, but it's still down. Why is it down? Well, one of the reasons it's down is because the other side of the serial link is still administratively down, shut down. So I'm going to go on the router on the other side. Now I'm going over to the 2511. Enable show IP int brief. Serial 0 is administratively down. So conft int serial 0. Note that serial 0 is administratively down. Let's scroll back a little bit here. This serial 0 is status down, protocol down. So it's down in a hardware sense. It's not seeing the electrical impulses from the other side, and it's down in a link layer sense because it's not seeing the any keep alive protocol from the other side. So int serial 0 no shut, and we'll give it a few seconds. We got our log messages. It was configured by the console. Interface serial 0's change state to up. Line protocol and interface serial 0 change state to up. Give it a few more seconds to stabilize. Show IP int brief. And oops, something new. Line protocol and interface serial 0 change state to down. So our router was up, our interface was status up, protocol up for a little while, like about, actually it looks like 20 seconds from when the line protocol went up to the line protocol went down. Now let's look at our status. Show IP int brief. Now we're in an up-down status. Electrically, physically, we are up. So at layer 1, we are up. We've physically cabled our router. We've no-shut our interfaces. But in a line protocol sense, we are still down. Why are we down? The reason is on synchronous serial interfaces, synchronous means that the time is synchronized. The DCE side of the serial connection needs to provide a clock rate to the DTE side. DCE is data communications equipment. DTE is data terminal equipment. The DCE side needs to send a clock. Let's look at that. The first thing we need to do is figure out which side is DCE. Show controller int serial 0. show controller serial 0. Prints out a bunch of stuff. Let's scroll back. Most of it only a programmer of this box would understand. But right at the beginning, at the second line, it says V35 DCE cable. So the 2511 is the DCE side. Let's switch consoles. Now I'm on the 2514 because I moved my console port. Show controller serial 0. Let's scroll back through the stuff that we don't understand. And there we are. On the second line, V35 DTE cable. If you look at that cable, you'll see that the side plugged into the 2514 is labeled DTE, and the side plugged into the 2511 is labeled DCE. But you didn't even need to go to look at the cable, and that's useful if these routers are in a lab on the other side of the building. All you have to do is execute the show controller serial 0 command to see whether on that synchronous serial interface a DCE cable is plugged in or a DTE cable is plugged in. We did not need to do this on our Ethernet interface. DTE and DCE is a synchronous serial characteristic specific to that interface hardware. Let's go back to the 2511, which is our DCE side. Conf T int serial 0 clock question mark clock space question mark. What is the question mark? In a Cisco router, when you're typing a command, at any point you can type a question mark and it will give you what valid options there are, if any, to complete the command, and then it'll go back to exactly where it was. So I typed clock question mark and it went back, clock space question mark, and it went back to clock. It actually printed out the clock space for me after showing me that the only option is rate. So I'll type in rate, clock rate space question mark. Here's a bunch of clock rates, different speeds. These are bits per second, so I can run the synchronous serial interface at 1200 bits per second or 4 million bits per second. Odds are, if I run it at 4 million bits per second, I don't know if it's going to be successful. In the lab, I usually run at 64,000 bits per second. You should be pretty comfortable running up to 1.5 megabits per second or 2 megabits per second, because 2 megabits per second is the clock rate of an E1 line, which is a common serial WAN link in Europe. But in the lab, I just go with 64K. So clock rate, 64,000. My interface is now sending, my interface on the DCE side, data communications equipment, is now sending a clock rate to the other side. So our synchronous serial interface is now synchronized between our two routers. And as a result, a few seconds later, the line protocol and interface serial 0 change state to up. So in the link layer sense, we are now up. Show CDP neighbors. I do show CDP neighbors. I'm not seeing CDP neighbors yet across this interface. And maybe that's because CDP does not work over this type of interface, or maybe CDP works, but only but it takes some time because CDP only advertises once every 30 to 60 seconds. So let's be a little bit patient. It's been I've been talking for a few seconds. Let me try the show CDP neighbors again. Again, I'm still only seeing the Ethernet 0 interface. But at this point, show IP int brief. My interface is now status up, so I'm up in a physical sense, and protocol up. I am up in a link layer sense. So great. Show CDP neighbor. There we are. CDP neighbor. My serial 0 interface, I am router 2511, and on my serial 0 interface, I see router 2514, and its interface facing me is serial 0. It is a capability R, which means it is a router, and it is a platform 2500. So CDP does work over synchronous serial interfaces with this encapsulation. What's an encapsulation? An encapsulation is a way to encode frames over this type of physical link. And the synchronous serial interface has multiple types of encapsulations that we can use. One is HDLC, another is frame relay. What encapsulation type were we using? We didn't configure an encapsulation type, so what type is the default? To find out, show int serial 0. Let's go back. Show int serial 0. Serial 0 is up, so we're up in a physical sense. Line protocol is up, so we're up in a link layer sense. Encapsulation HDLC. So we're running HDLC encapsulation, which, if I remember right, is a Cisco proprietary encapsulation. That's the default. It has very low overhead, works great for point-to-point links. So we're up in a link layer sense. We still can't ping the other side. Why? Because show run int serial 0. The show run interface serial 0 command does not work on this box. Let's do a show version. Our iOS version is 11.3 11a. So this is a pretty old version of iOS. We're talking like 8 years or something. So I can't do a show run on a particular interface, but I can do a show run. I have an IP address on my Ethernet 0 interface. We configured it earlier. On my serial 0 interface, I have my clock rate, no IP address. Don't worry about the mroute cache. Let's fix that. Int serial 0 conf t int serial 0 IP address 10.0.0.3 255.255.255.0. Oops, 10.0.0.0 overlaps with Ethernet 0. Well, I didn't type 10.0.0.0. I typed 10.0.0.3. This is my IP address, but when you do a bitwise AND with the net mask, the network that I just tried to configure is a 10.0.0.0. And my Ethernet 0 interface also has a network of 10.0.0.0. In fact, I tried to configure 10.0.0.3 here. Up here, I have 10.0.0.1. They're both /24s. Those IP addresses are in the same subnet. And I tried to configure them on two separate interfaces. A Cisco router will not allow you to configure the same subnet on two physical interfaces. And that's all it's saying. The subnet I just tried to configure overlaps with a subnet that already exists on Ethernet 0. Let's try a different subnet. IP address 10.0.1.1 255.255.255.0. End. Let me switch my console. I'm now on the 2514 console. Conf t and serial 0. IP address 10.0.1.2 255.255.255.0 and ping 10. Let me back out of that. So we just got a console message. Ping 10.0.1.1. So I am 10.0.1.2 and I'm going to try to ping 10.0.1.1. All 5 pings succeeded. All 5 pings succeeded. Previously on the Ethernet interface, the first ping failed because on Ethernet we needed to ARP for the other side. On a the reason we have to ARP for the other side is because on an Ethernet you can have many hosts on an Ethernet segment, and you need to identify the Ethernet address of the particular side that you're connecting to. Serial is different. Serial is point to point. There's always 2 ends to a serial link. Your side and the other side. At least for serial with an HDLC encapsulation, which is what we have. There's no ARP needed on this interface. When you have a packet that you need to send out, the interface You just send it and you know it's going to get to the router on the other side because there's no other place for it to get to. Now, if you ping an IP address that is not configured on the other side, like 10.0.1.3, you'll still send the packets out and it will still get to the router on the other side, but the router on the other side is going to ignore it because that IP address is not for it. And so you won't get a response and the pings fail. Great. That is, we have configured our interfaces. Let's do a show run again. Interface serial 0, the no IP directed broadcast, no IP mroute-cache, and no fair queue. Those are all default configurations for this 12.0 version of iOS. You can ignore them. We'll learn about them later. IP address 10.0.1.2 is the only thing we configured on this side. On the other side, the only thing we configured was the IP address and the clock rate, because the other side is DCE, so the DCE side supplies the clock. And on both sides, of course, we did a no shutdown command. So our network's up. Let's do a show IP route, because networks are all about routing. In a show IP route, it shows the route table of our router. What is a route table? A route table is showing which way a router sends packets. The show IP route shows that 10.0.0.0/24 it's a /24. It has two subnets inside the 10 net. The first is 10.0.0.0/24. The second is 10.0.1.0/24. They are both directly connected. So if we have a packet destined for 10.0.0.7, that is inside this /24, so my router will send that out the directly connected interface, which is Ethernet 0.